Hello everyone to our lesson on dividing mixed numbers. So previously we learned that dividing fractions, we keep the first number, we change division to multiplication, and then we flip to the reciprocal of the second number. All of that holds true for mixed numbers. We just have one step to do before we get to keep, change, flip, and that is to convert our mixed numbers to improper fractions. So for our first example here, we're going to do 6 times 3 is 18, and then plus 5 more will give us 23/6, and that's being divided by, in this case we have 1 times 3, or 3 times 1 is 3, plus 2 more is going to give us 5/3. So this problem is equivalent to 23/6 divided by 5/3. Now that we have a fraction problem, we can go ahead and keep the 23/6, change division to multiplication, and flip to the reciprocal of 5/3, which is 3/5. Now we have a multiplication problem. So I can see the 3 and the 6 are both divisible by 3, and it looks like that's all I can do. So on the numerator, 23 times 1 is 23. In the denominator, 2 times 5 is 10. Changing that to a mixed number, 10 goes into 23 twice. That would give me 20. So to get to 23, there would be 3 left over. So 2 and 3/10 would be my final answer. Alright, so why don't you go ahead and try this one on your own. 8 and 1/4 divided by 1 and 1/2. Remember that you need to change each of these to an improper fraction before you go ahead and keep, change, flip. So give it a try. Alright, so you should have gotten 5.5 for that one. Alright, so now that you have the fundamentals down, let's look at a few word problems. So the first one here, how many 6 1/4 inch pieces of fabric can be cut from a 75-inch roll? So notice we are starting with the 75-inch roll. So I see a lot of students say, here's a number 6 1/4, here's a number 75, I know I need to divide. So I'm just going to do 6 1/4 divided by 75. In this case, we need to understand the scenario because we're not starting with a 6 1/4 inch piece. We're starting with a 75-inch piece, and we're dividing it into the 6 1/4 inch piece. Alright, so let's go ahead and do that real quick. So 75-inch piece is being divided into 6 1/4 inch pieces. So we need to change to improper fraction. So this is 75 over 1 is being divided by 4 times 6 is 24, plus 1 more is 25/4. Alright, so now I can keep the 75 over 1. I'm going to change division into multiplication. I'm going to flip to the reciprocal of 25/4, which is 4/25. There's some nice simplification that can go here. 25 and 75 are both divisible by 25, and that makes this super nice. I get a 12 over 1, which is 12. So you can cut 12 pieces that are 6 1/4 inch long. Alright, so not too bad. Go ahead and give this one a try. This one's similar in the sense that you're starting with the 35-acre field and you're cutting it into 2.5-acre plots. So a plot is like, you could think of it as where a house would be, like the house and the land. So if you've got a 35-acre field, how many houses with the land can you create if it's a 2.5-acre plot for each one? So give that one a try. All right, so in this case, you can make 14 plots that are of size 2.5 acres, assuming you started with a 35-acre field. All right, let's look at another word problem. At a track meet, the longest shot put throw by a Thomas student is 25 feet 8 inches. The longest shot put throw by a South student is 19 feet 3 inches. We want to know how many times greater. So there's that times greater again. So we're not going to just subtract. We actually need to set up a multiplication, and then we're going to set up the division problem. Now, before we get anywhere with that, we need to create some mixed numbers. So 25 feet 8 inches is equivalent to 25 8 inches. 8 out of 12 is simplified to 25 and 3. Nope, sorry, 2/3. 25 and 2/3 feet. All right, so that's for the Thomas student is 25 and 2/3 feet. Now we have to do so I'm going to write that down here. Thomas is 25 and 2/3 feet. And then South, let's do that one real quick. South is 19 feet 3 inches, which is equivalent to 19 feet and 3 out of 12 inches, which is 19 and 1/4. So South is 19 and 1/4 feet. And it asks us how many times greater is Thomas compared to South. So again, it's asking us 19 and 1/4 times what is equal to 25 and 2/3. Now we can rewrite this as a division problem by saying, well, 25 and 2/3 divided by 19 and 1/4 equals what? All right, so let's go ahead and do that. So 25 and 2/3 is 77/3 being divided by 19 and 4 is 76, and one more is 77/4. Ooh, how convenient. All right, so 77/3 divided by 77/4 is equal to 77/3 keep, change, flip to the reciprocal. I like that a lot because we have 77s that simplify, and we have 1 times 4 is 4, and 3 times 1 is 3, which is 1 and 1/3. So Thomas students is, the Thomas students throw is 1 and 1/3 times greater. Notice my unit is times greater, and it is not in feet or inches. All right, that was a big one. Here's one for you to try. It's not quite as involved, but again, you want the heavier rock compared to the smaller rock. So you're going to divide 16.5 divided by 10.5. That will tell you how many times heavier. All right, so in this case, you get 1 and 4/7 times heavier. Last but not least, we have another challenging word problem. So we were trying to make skateboard ramps by cutting pieces from a board that's 12.5 feet long. So on the left here, you can see we want ramps that are 1 7/8 feet long. And we have a big piece that's 12.5 feet long. So estimate how many ramps can you cut from the board? Well, if I'm at about 12 and this is about 2, so if I have about 12 feet and each ramp is about 2, I would think that we would have about 6 boards. Now, since this is a little more than 12 and this is a little less than 2, you might even think 6, or we might squeeze out a 7th board. So let's check this out. We have 12 and a half, and that's being divided into 1 7/8 pieces. So convert to improper fractions, so that's 25 halves, divided by 15/8. Now go ahead and keep, change, flip. Then let's simplify before we multiply. So 8 and 4, 25 and 15 are both divisible by 5. So we get an answer of 20/3, which is 6 2/3. So that tells us we can make 6 full boards. We can make 6 full boards. So you can make, or not full boards, 6 ramps. You can make 6 ramps. Then it asks how much is left over. Now we have 2 ways to do this problem. One way is to figure out, well, if I made 6 ramps, we could do 6 times 1 7/8, because each one is 1 7/8. And whatever we get from that, we can subtract it from 12 and a half. So that would be one way to do it. The other way to think about this is I have 2/3 left over. 2/3 of a 1 7/8 ramp left over. I only have 2/3 of it. I don't have all of it. So remember, 2/3 or a fraction of something else means multiplication. So I could do 2/3 times 1 7/8. Let's go ahead and convert that to an improper fraction. So that's 15/8. Now notice I'm multiplying. I don't have to change or flip anything. It's already multiplication. All right, so quick simplifying. 2 and 8 goes to 1 and 4. 3 and 15 goes to 1 and 5. So this is equal to 5/4, or 1 1/4. So this is how much is left over. So 1 1/4 feet of board is left over. Which makes sense, because 1 1/4 is less than 1 7/8, and it's pretty close since I had 2/3 of that ramp left over. Alright, so give this one a try. It has to do with, oops, plot twist. That was the answer. Alright, don't look. Let me erase this. Alright, so give that one a try. So you're starting with 36 cups of flour. How many full loaves of bread can you make? And is there any left over? If so, how much? So give that a shot. Alright, after dividing, you can make 6 loaves, and there's 3/4 of a loaf left over. So 3/4 of the 5 1/3 cups that is required. Do the multiplication, and you have 4 cups of flour left over. Alright, that'll do it for today's lesson.